equations. And all we'll do tonight is we'll do the very, very simple ones, okay? So I'm going to use my unit circle and kind of refer to that. So now we're going to solve equations, okay? So all this stuff with inverse, a lot of this has to do with equations. Trig equations are a big deal in higher math. They show up all over the place. So what you typically do is, not always, but a lot of times I give you an interval of where I want the trig equation solved on, because actually this equation has an infinite number of answers to it, so I'm going to narrow it down to 0 to 2 pi. So what you do is you do the very typical things that you're used to doing when you solve equations. You isolate the trig function. So what we're going to do with this, and you can do a lot of this in your head, I don't mind if you do this in your head. So what I'm going to do is I'm going to isolate the cosine, so I need to subtract 3 from both sides. Okay, when I do that, I'll have 2 cosine theta is equal to -1. Okay, then I need to divide by 2. So if I do that, I'm going to end up with cosine theta is equal to -1/2. Okay, like that. Okay, so that's the idea. You start that way. You're typically always going to start that way. Now, students, a lot of times when they're solving equations, start getting mixed up in their mind the inverse cosine and the inverse stuff a little bit. When you're solving an equation, I want every answer on this. So what you're going to do, the unit circle is giving you the 2 answers to this problem. Where are all of the places where the cosine's -1/2? There's 2 places. Where are they? One of them's right there, right? Cosine's the x value. 2 pi over 3. Where's the other one? 4 pi over 3. I want both answers. The reason I want both answers is because we're solving an equation. Okay, we're not working with an inverse. We are solving an equation. So if I give you an interval, I want everything now. Okay, so your answers on this are going to be there and there. Problem done. Okay, that is 2 pi over 3. And 4 pi over 3 like that. There's your answer. That's it. That's all you do. You're going backwards on the unit circle when you do that then. Okay? All right? Now, why don't you get your calculator out if you remembered to bring it, because I want to do this a little bit on these problems, is you can tell you're right. Okay? You can solve any equation with technology of this sort. So what I'm going to have you do on this one is, first of all, put your calculator in let's put it in radian mode since we're doing graphs. Let's do that real quick. And let's put in like this. Okay, let's go put in the left side of the equation. Put in 2 cosine of x. Instead of using theta, use x. 2 cosine of x plus 3, like that. And then put in the right side of the equation, which is a 2. Okay, so we want to get that put in. And you should be in radian mode. And what we're going to do is we're going to find where these 2 curves intersect. Now do your window. So your window, we're going to go 0 to 2 pi on x. That's what I told you to do in the directions of the problem. So go 0 to 2 pi. Not like that. 2 pi. Okay, scale it, it doesn't matter. I don't care. Leave it as a scale of 1. Who cares? Okay, and then for the y's, let's go like something like -5 to 5. Or let's do -6 to 6. Now the reason that I'm figuring that out is because of my knowledge of graphing. That's a cosine with an amplitude of 2, shifted up 3. So that 2 goes up to 5, like that. That's how I know that. Okay? So if you get all that put in and you type graph, you're going to get the cosine curve coming out, and then you're going to get the line y equals 2 coming out. And it's going to intersect in 2 places. Those 2 places should be the answer to the problem. Okay, everybody with me on that? Have we got in your calculator what you're supposed to, or I need to show you? That's what you put in. Both sides. Window. Do that. And radian mode. If you're in degree mode, you're not going to get what I'm getting. So check your mode. Okay. Now, what we're going to do on this is we're going to trace our answers. This is how you verify with technology. So type trace and then put in 2 pi over 3. Like that. Ah, that's good. Okay, you can tell. Okay, now trace 4 pi over 3. And let's see if that comes out. Oh, look at that. Isn't that cool? Well, visually, you can tell you're right on an equation. You always can, okay? All right? So the question is, why don't I just do this with my calculator? Well, you're going to learn much by that. You learn the verification and the geometric part, but you don't learn the theoretical part of that. And that's why you need to know that. Okay, let's finish up class with just one more. And that should be kind of at least get us started in here. So what you do on this one is when you do tangent squared theta equals 3, well, think back you're in trig or college algebra. What do? You just take a square root of both sides, right? If you're undoing a square, you're going to take the square root of both sides. So what that's going to give you is tangent of theta equals plus or minus the square root of 3. Okay, so we need to figure out all of those answers from 0 to pi over 2. Okay, so here's what happens on this one. Now this time I'm going to take this approach. I'm going to have you just draw a little diagram on there. So let's do a triangle in quadrant 1 just to start with. Okay, and kind of look at it like this. Sometimes I like to kind of vary the approach and get away from the unit circle. So you know that the tangent is y over x. Okay, so y would be square root of 3. X would be equal to 1, like that. What's r? 2. What is the angle right there? 30 or 60? 60. That's a 30-60 right triangle, right? Okay, so that means that one place where the tangent is equal to square root of 3 is 60 degrees, okay? But the other thing is we want it also to be negative square root of 3. So basically you're going to have 4 answers to this problem. One of those answers is going to be at 60 right there, okay? Where's another one? Well, the other place the tangent is positive is quadrant 3, so it's going to be also there. You have that answer. But then where is the tangent negative square root of 3? There's 2 places. Where's that? Here and there. So you got 4 answers. And the reason you have 4 answers is because when you did the square root of both sides, you had the plus or minus square root of 3. Okay? So that's the idea, is when you write your answers on this, you want this to be in radians. You would have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. You guys see what I'm doing on that, okay? The reason is the plus or minus, okay? If I didn't do that plus or minus, I wouldn't have those answers, but I have an answer in every quadrant like that. And that comes from the fact that the tangent takes on the value of square root of 3 there, and then it's negative there, then it's back to positive there and negative there. There's 4 answers. Does that make sense? It's because plus or minus. You had to do that plus or minus. There's an answer everywhere, every quadrant. Okay, that wraps up for tonight then. Have a good weekend.